Hello, my friends. Hello. Hello, my friends. What's up? Hey, friends, what's up? How are you doing? La la la. Alright. Alright, my friends. Let's go another. Today, it is not mental masturbation at all. We want to code, we want to see the result. Then we want to go to the gym after working hard. Is to work out hard. But boom, we want to eat lunch. Then do some crunch. Irene webcam running on background. Guys, oh, I see. It's all good. Let it run in the background. Now it's the time for, yep, Gaussian. Gush it up, gush it up, gush it up, gush it up. Let's gushing it up, gushing it up, gushing it up, gushing it up, gushing it up. We start the gushing with some caution. Last time he said that's enough. We are gonna code. Oh shoot. Well, I have 37% battery, so I don't think it's a huge deal. We won't be on the iPad hopefully today for long. And let's go. Exactly. Anaconda, Python, Anaconda and Python and code programming. Guys, I feel I'm getting smaller. Let's confess that I did not hit the gym. I can see myself in the camera and I can see that the part of me that are gone. But part of it, let's make my excuse of the day. It was because I was going to the physical therapy, and now it's hopefully gonna finish in 2-3 weeks. I can, or will be less frequent. I can be back to the gym. I wanna go back. I wanna code more. Okay, this is it. This is the code about the. Now I wanna have the code. By the way, I don't like it here. I wanna open this. Now launched. I was talking to Avol on weekend. He has a lot of good points on mental masturbation. Um, we should tell him to come and share with us his experience. Benchmark. No, I wanna write a new code. This changes the history. History changes from before this code and after this code. We wanna call this code seminal. Seminal, is it the word? Relating to, containing, or no. Ew. Wait, seminal is an adjective that means relating to, containing, or consisting of semen or seed. It can also mean having a strong. Oh my god. Okay. Seminal. Influence later. His seminal work on chaos theory. Oh my god. Okay. I won't call it seminal, but I will call it the best code of the year. Best code ever. That's it. The code of ever. Best code ever. Okay, best code ever. Rename and time to share with you my point of view. This is the best code ever, and wait, this is also the best code ever. How does it work? So we have best code ever, and in best code ever we wanna feel nirvana. What do we want? We wanna code the you know what I wanna code? I wanna code a graph. I wanna code graphs for this problem, optimal revenue, which is not complete yet, but we have some terms for it. After this part, this is completely old and not correct. So what are the parameters? For writing the best code ever, we may want to look at our benchmark because we have some parameters there. Import numpy as np from typing. Yeah, let's have these. Let's copy the whole code. Control C. We should start from somewhere. For having the best code, you may start from another code which is not the best code, or you want to start from a code that is mildly good. Does it mean that this starting point doesn't matter? It matters, but more important than the starting point is just to start the point. Okay, now I want to import numpy as np, why not? From typing import list, why not? Import matplotlib from pyplot as plt, why not? N is 3, let it be. S is 1, let it be. T is 1, let it be. Mean theta is 0, let it be. Variance, okay, we will play with mean theta and mean omega for sure we are gonna play with mean theta and mean omega because it changes mu ai, and as we know, by changing mu ai we will have different values for x greater than or less than, above or below sigma ai theta I over sigma t sigma theta I squared, which we want to know where is it the optimal for the optimal revenue. No. Optimal revenue compared to welfare. Okay. F is 1 over n minus 1 is error. Fuck that. We don't need it. We want to definition. I definished this. And I also have another code can give us better understanding. So let's change the name of the code from Thibaut to old revenue. Best code ever wants to implement the optimal. Okay, he has like a structured data class, normal float. Okay, what we are going to do. So we have these coefficients. The way he solves the problem is a bit different. Let's go. What are the equations we have in the best code ever? What do we want to do? We want to plot. That's what we want. We want to plot revenue, and after that we have other codes to do too, for different values of R. That's what we want to do. So we have this payment or revenue, not much different, and we want to plot it. All right. What are the equations we have? By the way, we don't have the full thing here. Full thing here. Full picture. Full circle. Okay, it is here. All right. So we have lambda, which is the variable we are going to find, and we have sigma I omega. Let's check what we did in benchmark. So yeah, in benchmark we say that these are these variables, and GR, what is GR? The polynomial that gives us the equation. Here the difference is that we have to solve two equations, right? First we need to find lambda, okay, that's here. So we have nu, we have sigma I omega, we have sigma I theta j. Okay, this is the equation. Second equation is binding, which is this one. Am I right? Oh, no. This is this one, which is, yeah, this comes from stability, this equation. So this equation comes from stability. We have nu, we have sigma I omega. What I want is okay, this comes from KKT. KKT gives us this inequality as equality, and so this gives us equality, which we will compute sigma AIAJ, and exactly sigma AIAJ. But we don't need sigma AIJ much, to be honest, right? For now, let's not compute sigma AIJ. Why do we need it? We have this. At the end, we can compute sigma AIJ by putting it. Oh, okay. We need it actually. Maybe we compute sigma AIJ. Put it in the first, because the first one can be equality or inequality based on the value of lambda. If lambda is positive, we have both of them as equality, and we can find sigma A theta, we can find lambda. If the second one, lambda is 0, this is a strict inequality, and we have to find the value of delta that works in this equation for maximally anti-correlated. Right? So, okay, what is the situation? We want to solve two problems. Let's find first find the easier case, where everything is binding. Right? Let's do that. Yeah, let's find the case where lambda is first, which happens more often, by the way. Let me also share with you. Oh my god, guys, I have to pause it for a second. I will come back. Okay, guys, let's go. Control Shift 2. Okay. All right. Um. So first, we wanna consider the case where it is deterministic. Uh, Deterministic. Therefore, lambda is positive. The equations we have is nu. This one we have forever. Lambda f minus r minus r. So, fuck it, I won't write it. Nu given by lambda sigma ai omega by lambda sigma ai theta j. We also have the formula for it by obedience. I see. Sigma ai j and sigma ai squared obedience so the parameters left: lambda sigma ai theta I sigma ai aj. Sigma ai aj, what do we have about it is KKT second PSD. So we know that it gives us, right? Should I write it down? I think I need to write it down. Do we have it here? So r squared sigma theta I squared 1 plus r sigma ai theta I minus t sigma theta I squared n over this squared s sigma ai omega t sigma ai theta I n minus 1 plus r. All good. I will take it. Let's take both of them, because now both of them are binding. Copy. Okay. So we also have these inequalities as quality in the deterministic case. Therefore, therefore, let's remove -1. Okay, even we have the equation that gives us by the way, r is negative. Note that because r is negative, denominator do not vanish for a dual feasible. Oh, you don't have me. So, oh, you don't have this page at all. Alright. Should keep it up. What is the right ratio for this, by the way? I have no idea. Nope. Okay, this is the biggest it can get. Well, I don't know. Okay, the ratio is like 1080 90 20, right? So 1080 times 90 20. If I want to give it too small, up to here. If x is 1258, you don't see the computer. 1258, right? What should be this? So the answer is 1258 times 1080 over 1920. 707. It's close, all right. That sounds good. Okay. These were side notes. So we also have the equation that we want just sigma ai theta I. So we are left with sigma ai theta I and lambda. Those are the things we want in the deterministic case. And the equation that gives it to us is so I got it wrong. The third stability constraint gives us sigma ai theta I based on lambda. So okay, third stability. So the second PSD gives us sigma ai aj based on sigma ai theta I sigma ai omega. Third stability constraint gives us which is the derivative of the second PSD, gives us sigma ai theta I as a function of lambda, which is, let's write it down, 2 over r squared sigma ai theta I t sigma theta I squared lambda nf f minus r minus r 1 plus r minus 2 over r squared minus 2 over r squared lambda nf f minus r minus r God, minus lambda nf minus r over 1 plus r, and then it equals to, I try to put it in one line later, mu ai squared t squared sigma ai theta I squared, not theta I, theta I squared t sigma theta I squared over sigma ai theta I, the whole ratio squared. Over r squared sigma ai theta I, then minus r minus 2 over r squared lambda nf minus r minus r minus nf minus r. Oh my god, 1 plus r, oh my god, it feels mu ai t squared sigma theta I squared t sigma theta I squared over sigma ai theta I squared. Now let's make the line. No. This is a big shame. Okay, it's impossible. It doesn't make sense. You don't have enough room. That's it. That's nice. Oh, but we have f lambda and g lambda, right? So our f lambda, oh, it is f lambda, 2 over r squared minus r, g lambda is 2r squared, lambda and f, and then okay, that's it. Now we have sigma aj, we have, which gives us sigma ai theta I based on lambda. That's all good. Now we want to use first PSD, which says let's remove sigma aij from it. Where are they? here. I see. So actually I can make it big now. So we wanna also change sigma AI omega based on the value of R. Yeah, that's it. We should do the dirty work. Let's not procrastinate. Guys, sounds like a simple high school task. Therefore you say, oh, this is so easy. If it is easy and boring, just get rid of it earlier than later. Just finish it so you can get to the interesting stuff. Just it's so big, I'm lost. So we wanna multiply the first equation in 1 plus r and the second one in f minus r. Both of them are equalities, and regardless of sign of r, they are what? They are positive. They are positive. Both are positive. Yep. So they don't change the direction of the inequalities in case we want to later use the same computations for non-binding. For example, if I want to add a plus epsilon here later. So we have 1 plus r over r squared sigma theta I squared f minus r plus n f minus r sigma omega squared sigma ai omega squared, right? N f minus r sigma omega squared over sigma ai omega squared 1 plus r squared sigma theta I squared f minus r bada boo f minus r squared sigma theta 1 plus r sigma I theta I minus t sigma. Okay, that's it. Then what is left? The other side equals 1 plus r sigma I omega 1 minus f minus r, so it will be 1 plus f s sigma ai omega, and 1 plus f. Okay, what about t sigma ai theta I? The same thing. Theta I, and those terms will cancel each other's out. So that's great. We did. Woo! Great job, guys. We did a big part of the problem. Got rid of sigma ai theta aiij. Now that we did it, let's go change sigma ai omega by lambda based on lambda, and sigma ai theta I is a function of lambda. So this is the equation that we want to give us the lambda. That's what it is. We have a sigma ai omega. I see. So that's what it is. Can I change its colors? Oh yeah, we can change its color. Change style. That's good. Okay, but I wanna say, so we have one equation for sigma ai theta I and lambda, which is a degree 3, or you may say f lambda x minus g lambda equals c over x squared, and the other one is this equation. But this equation, if we change sigma ai omega based on lambda, if you change this sigma ai omega based on lambda here, so it's a ratio of two affine functions, then let me write it here, sigma ai omega. Keep your goal, sigma ai omega equals s sigma omega squared over 2n lambda nf plus 1 over lambda f minus r. That's it. So this one gives us another equation for lambda. So we have two equations for lambda and sigma ai theta I. If I want to write it, it will be like move it down. This one as well, plus nf minus r sigma ai omega squared. I should change it to this. Copy. Actually, I like it. Now we can learn how to solve two equations, two parameters two variables in Python. Maybe MATLAB was a better space, but I want to learn in Python. This is a square, right? S sigma omega squared over 2n lambda n f plus 1 lambda f minus r minus r. Alright, maybe make it nicer. And what happens if we add delta? This is very. We should carry delta here. Okay, now let's move this here. I want to keep the equality sign here. Come here, you. And then we have come here too. Change sigma a omega. Wait, that's yeah, copy, paste. And maybe the whole thing's a bit small. Alright. So this s should be s squared now. So we again have another equation, just sigma ai theta I and lambda. So this is our first. This color, cyan, whatever. I can barely see it. It's not a good color. Purple. Indigo. This is black actually. Indigo. This is good. This is black too. I don't get it. Fuck it. Yeah, I need a. Oh, okay, I didn't change the color actually. How can I choose this color? Yep. Wow. No. What is this? I want this. I want this. Oh, okay. One. This is our first. What a nice color. And the second, which comes from the stability, I don't have it. I just added it. Sigma I. No, not here. This is it. This is our second one. So these two gives us, that's a nice color. Okay. These two, we need to solve this. We know lambda is positive. It gives us sigma ai theta I as the unique positive root. of this equation, right? Exactly. And here what we will have is a degree. What will be the degree of this equation? You have like a degree 2 equation, but it has multiplication of, so it is in general. So it has multiplication of lambda and sigma I theta I. It's not as easy. Mm-hmm. If we look at it only as a function of the ratio and sigma I theta I, it's one quadratic one side, the other quadratic another side. Probably an ellipse, like sigma I omega and sigma I theta I. That's what it is, right? Exactly. This is what it is. Sigma ai omega and sigma ai theta will be on an ellipse. But what is the ellipse? Is it the same ellipse that we were talking about? Yes. This is the ellipse, and we have these curves. Exactly. This is the ellipse we have, right? And the curves of sigma I omega of lambda and sigma I theta I of lambda comes from this one and this one, right? So let's solve the problem like this. Let's not bring, let's not have this ugly equation here. The way I want to code is, we have sigma I omega, alright? We have sigma I omega as a function of lambda. We have, you tell me guys, we have sigma I omega of lambda. We have sigma ai theta I as a function of lambda. We compute those two, alright? Then we check if it is inside the ellipse or not. That's what we want to do. Let's have this equation as our ellipse here. Exactly. This is our ellipse equation. That's our ellipse. Then we solve those two and check if it is in the center of the ellipse or not. Sounds good to me. Let's do that. So we have this equation gives us sigma I theta I of lambda. Benchmark, best code ever. And it's serious is this. Okay, for different values of R. The thing we want is just computing it for different values of R. So, okay, that's what makes it more difficult compared to the benchmark. For the benchmark, we had the solution already, right? Okay, we could find the solution to the problem by only solving one equation. Here, we wanna find the solution to one equation and then check if that solution but in the ellipse equation we don't have any lambda, right? So for different values of lambda, okay, here we have two parameters. One is lambda and one is R, right? That's what makes this code more complicated. We have lambda and R. One time we compute the curve of lambda, sigma I theta I of lambda, and sigma I omega of lambda. So we have this curve, fix R for now, and we have an ellipse, and we find the lambda, then it cuts the ellipse or is inside. And how we do it is just saying, okay, does it work for R0? Lambda is not 0. Does it work for lambda equal 1? Are we inside or out? If it is inside, we divide it by 2, lambda equal 1/2. Are we inside or out? Like this bisection method. Or if lambda 1 is out, we are gonna find it's lambda 2 is inside or out. And doubling every time lambda. That's it. Then we want to do the same thing for different values of R, right? So let's keep the R fixed once, solve the problem, write the code for the easier case. I want to do that. I want to give myself this easier challenge to solve the problem for a fixed value of R, then try to generalize it for the cases when R ranges from -1 to 1 over n minus 1, and then see what's up. So benchmark was kind of easy. That's why it's called benchmark, not the best code ever. So let's say R is minus 0. I don't know, should look like now. Computer posture. R is this. I fixed R. Let's put a comment here for myself. Fix R for now. Fix R and ellipse for now. Okay, that's good enough. So this function gr will change later. I don't want them. No more. And maybe once I write this code and second stage, I will look at Thibaut's code, because if I look at him right now, yeah, may I finish earlier, but I don't like. I want to learn to do it myself. This is my ellipse. I don't want that. What are you watching, by the way? Okay. All good. I will change this stuff too. Okay. So we want to have a function that gives us sigma ai theta I. Alright, how do we write sigma ai theta I, by the way? Alright. Sigma ai omega, sigma ai omega, or y, okay, y, let's call it y, because sigma ai omega equals y times s sigma omega squared. Okay, y equals lambda. What is lambda? L. Yep. L is I don't know. L is range numpy and PRA, something like that. Dot. We will find it out. Oh, something happened to my keyboard. I don't know how it happens, but cancel. Shift enter. I don't give a fuck. Leave. Come back. Benchmark. Best code ever. Alright. Arrange. Actually, we don't know what is the value of lambda. Let's say 0 to 100. What is that? 1000, and it changes by 1. Y equals 1 over 2 and times I'll call it lambda. Oh, we cannot have lambda. Okay. L times n times f plus 1 over L times f minus r minus r. That's it. And 1 over 2n lambda nf plus 1 lambda f minus r. That's why we need g as a function of least to our flow to list. Why are we returning a list? No. Def gr flow to float. Now df fucking not g, because we have f and g, h. Cubic. Def cubic. It should be blue. Benchmark. Yep, should be. Alright. Def cubic. Input is L. Float to to another float, and then I want to put this. What is this qubit? Root. We should use root function. Now it looks like the benchmark. This is it. Do we have it in benchmark by any chance? F minus 2R and F. What is it? Where is F minus 2R and F? Oh, okay. Okay. Benchmark is for 2R. Yeah. Let's find the solution to cubic by just making it a cubic equation. That's a smart, because now it is like F lambda x over minus g lambda equals so join me here, guys. I want to use the root function. So it's black 2 over r squared, as we said before. Fuck that. It's f lambda x minus g lambda equals c over x squared. So it's f lambda x cubed minus g lambda x squared minus c 0. That was easy, actually. Okay, what are the solutions? F lambda x cubed minus g lambda x squared minus c equals 0. My code. Alright. Root function. We have it in benchmark. Coefs. Okay. So coefs. Equals f lambda. What is f lambda? Equals two over r squared times L times N times F times lambda and F minus R, F minus R, minus R times 1 plus R, right? That's nice. 2 over R squared, lambda and F minus R minus R times R plus 1, G equals, should have minus G, minus G, which will be no, minus G will be minus 2 over R squared, right? 2 over R squared lambda times N times F times F minus R times F minus R, right? Minus 2 over R squared, lambda and F minus R, and then minus, I should not do that. L times N times F minus R over 1 plus R. Let's go, guys. 1 plus R. We did it, guys. We are doing it. And we have 0. And we have C minus C, which is minus mean A. Did I define mean A? No. I should define mean A. Oh. Mean A squared over T squared minus mean A over squared over T squared sigma A theta I minus T squared sigma theta I times var theta. That's it. So it gives us x. X is the solution to then we want to find the root. Let me just also mean A. This is not true, but close enough. Close E. What happened to you guys? Are we on? Yep. All right. Mean A. What is mean A, by the way? A is S mu omega plus T mu theta I 1 over 1 minus n minus 1 r. Okay. Yep. Mean A equals T mean theta 1 minus n minus 1 times r, right? I bet I'm right. Just put it, doesn't matter. Doesn't matter. It's mu omega T mu theta I 1 minus n minus 1 r. Good memory, guys. Just trust your memory. Woo! I got a good memory. Alright. I got a really good memory. Fuck it. Alright. This is all we want, right? Mean A minus mean A squared over T squared var theta. And then we are going to find the root for it. How do we use, let's root function. Do I remember the syntax? I don't remember. So I want to say something like x equals root np dot root, whatever, root of, for example, coefs, and then the positive greater than 0. That's what I want. Benchmark. Okay. Okay, doesn't matter. X equals np dot max. That's good, that precision. Maybe later. Yeah, that's one unique real. That's it. That's a good equation. 3 and so we are returning this, right? There is no f on x right now. We can return y here too. Yeah, why not? Y equals this. Let's put the y also in the function. And so we are gonna have a list of floats, right? Benchmark. Yes. The thing about lambda is that we cannot choose it in array. The real thing that we have control over is R. Okay, well, I'm thinking ahead. Let's finish this first, and then we are gonna go over how to choose R to give us the value of lambda we want. Now we are getting lambdas taken, which is a big thing to say. Actually, the challenge was not here. The challenge is where we wanna find lambda by changing R. Okay, good. We got rid of the easy part. Now we are going for the main challenge. That's it, right? Return this. Do you want to plot some stuff to check this code works or not? No. We don't have that. Why? What is wrong with it? What's wrong with it? Oh, okay. It's not a list. What is it? Min a squared. What is wrong? Int object is not callable. Perhaps you missed a comma. Where? Okay, the plots, I mean, R is not defined. Define R, motherfucker. Control X. What about no? What is int? Who said load? Oh, I'm back to that mode. I don't know, is it this? No, it's not this. There is a key on the keyboard that you press it and it starts changing. Now it's load flat. If I press shift, it will be flut. No, it won't. Evolution. Yeah, I don't know who uses this type, but what if I write float? Ah, fuck. This sucks. Leave. So, benchmark. Yeah, I don't know the shortcut key to get back to normal, so. Okay, load, float, float. What else? Okay, as long as we are on the plots, we're okay. For now, let's. Actually, remove that. What do I say this? Let's check how cool Python can be. I want to give it a vector, like from 0 to 100. And I want to go 1, but what I want is here I want to just say function. Okay, not a big problem though. L, and for example cubic of L, right, of 2. Um, cubic L, and for example the first sigma x. Oh fuck, again it got, oh, okay, it didn't. Cubic 1 L1, and x label will be lambda, and y label will be sigma a theta I times t times theta. Not t squared, by the way, we're just times. Yes. What is rank? Line 19, int object, not callable. What's wrong with it? What is the int object that I'm calling? Int object is not callable. ChatGPT. Okay. Okay, so there is a star left. Oh, return. What the fuck? Yeah. We didn't read. Where is it? Best code ever. We are gonna make it best code ever. Return. That was funny. Oh, okay, here. Why are we value? Okay, x is x vals. What is x vals? Oh, y vals is zipq. Oh, we should do it in this way. I see. It's like a one line function. Nice. What's the time? Yeah, let's finish this part first. Then we go for a break. Where is this? Where? Can you show us? Code. No, that's the best code ever. Oh. I think squared over t squared. Alright, now it's better. Now the rest is about the, what is the comma? 4 L in NP range. L in NP that range 0, 100 and 1. XY NP.array. Well, actually, this is much cooler to use that one line. What is it? Zip star cubic valve. Alright, let's do this. Dude, ChatGPT understands, motherfuckers. I see. X valve. So here we need to cube X valve. Valves. I don't like X valves. Y valves, by the way. X valve. X. What's wrong? What is the int object? Okay, let's do this. After minus 2 over r squared. Where is? Where? No. Here. Now it's like, okay. Best code ever, where are you? Fuck. Okay. Oh, because now it thinks it's an input to an what's the function? So sigma AI theta I as, yeah, we are going to the inside of the ellipse. And how is y? Let's just say y. Y is also so, and they're positive. Let's go to our curve. This curve suggests we are going like this, but our graph shows we are both positive. However, it is not y and x here. What is the value of r and s here? R is negative, t is negative. When t is negative, and again sigma I theta I is the second variable, so yeah, makes sense. I agree. We are good on this. We are good on this. All right. Dude, honestly, what limits society is electricity outlet. We could go in a park. We need to just, instead of every 10 flower we plant, we need to plant an electricity outlet too. Actually, it will be very cute if you have a flower like a artificial flower that has the electricity outlet on it, and people then can go to parks and just use their laptops there instead of sitting at home. We can make it, at least for summer. In the winter we can put some ceiling and go to places which are called cafes. Even in the winter, some people may want to wear in their jackets in parka, and they are very tough people who are coding. Yeah, just, I think the only thing that, well, we can put that flower in like a box, right? We can put the flower in a box. I should talk about it with Ryan, by the way. Ryan, you are an architect. You are an architect. Tell us if it is applicable or not. So we put just the electricity outlet, or we can put it like a hot or ceiling or like an umbrella. I don't want to make it a house. That's what I'm saying. I don't want to make it indoor space. So we make it in a way that, like, if a squirrel wants, they can get. It's like this air walls. Is it called air wall that you go into a shopping center in the in summer, and the door is always open, but it doesn't let the cold and warm weather mix. So the same we apply. We can have fire. We can have fire inside that. Like we have a ceiling for sure, and we have some fire spots, but the surrounding is open. Well, you are in Boston. You don't want the wind probably, so we need something to block the wind. Not a wall, but not a wall, and not like a glass window. Something that we want it to be transparent, and we want it to be walkable. It's just like air, like the air walls, so you can just walk through it, but the wind doesn't come in. Also, the ceiling is made of like glass or something. Air wall. Is it called air wall? We need air wall for the ceiling too. Well, not for the ceiling necessarily, But we want the ceiling be transparent. Plastic works. Plastic works. For the ceiling, we can use transparent plastic. For the wall, we want it to make of air. What is an air wall? Yes. Air walls divide rooms without a physical barrier, sometimes referred to as room or space separation line. Walls, typical use cases. Circulation, separating an open office desk area. Oh, separation. Oh, okay. What is circulation? Air circulation. Right? No, it doesn't look like that. You know what I mean, right? It's like an AC. It's not AC, but once you get into a storage, like a stream of air comes here, and it's just. Yeah. We have to have better ideas so that we can go in open space and code there. And like a squirrels come or somebody can has his dog. I don't know. Best code ever. Okay, we did best code ever. This part, I think it's okay. The main challenge still remains where we are drawing ellipse, right? We are drawing our ellipse with different values of r. And okay, for each value of r, we want to find a lambda. That's what we want to. For each value of r, we have an ellipse, right? This is easy. This is easy. For each value of r, we have. So that's not difficult. I don't think it is difficult too. For each value of r, we have a lambda. How is this lambda? We find the smallest lambda that puts us into the ellipse. We have the equation for ellipse and we want to come back. Yeah, let's come back. Not only me need a break, my tablet needs a break too. Get some charge. Thanks to Ryan. Thanks to Ryan for working on this project for me. I think actually that will be great.